Just before we start, I want to show you something cool about scientific notation in the Ti-84+C calculator. If you do, for example, 1 and then second, this little comma button will be EE, but that's scientific notation. What that really means is times 10 to the power of whatever's next. If we do 1E5, that is, for example, 1 times 10 to the power of 5. If you do 6E2, that's going to be 6 times 10 squared, which is 600. Now, if you want to do a really large number, you would do 1e to the 99. That's 1 times 10 to the power of 99, a huge positive number. And then if you want to do a very large negative number, we'll do negative, not minus, but negative, 1e to the 99. And that's going to give you a really large negative number. Now, if you want to get areas underneath a normal distribution, and you have your bounds, even without z-scores, you can do it. So what we should do is we'll get second, then vars will get us to the distributions. We'll go down, press the down arrow to get normal CDF, and then we'll enter. Then we'll see this lower number is just a really huge negative number. And then the upper number is going to be our upper bound. Then we have our mean mu and standard deviation sigma. So what we'll do is, let's say, for example, we wanted to know if we were looking at a standard normal distribution, so the mean is 0 and the standard deviation is 1, what's the probability that a z-score is less than 2? So it could be negative 1,000 still, that's possible, but it cannot be higher than 2. So we'll put lower super negative number, upper 2, mean 0, and then sigma 1. We'll go down to paste. Then we'll press enter again because this just pastes an expression for the calculator to use. And the probability that the z-score is less than 2 is 0.9772 and so on. But you see this in the z table because this uses mean of 0, standard deviation 1, and this is exactly area to the left of a z-score of 2. Now let's see, what if we had some real life data? What if we knew the average height of a person was 70 inches and standard deviation 5 inches, for example? We'll go second vars to get distributions, and then we'll go down to normal CDF again. So we'll put right in our mean of 70 inches tall, and our standard deviation is 5 inches. Let's say we wanted to know what's the probability that someone is between 65 inches tall and 80 inches tall. Well then, we'll put 65 as our lower and 80 as our upper, and then we'll go down and paste, and we'll hit enter twice. So here, the probability that a person is between 65 and 80 inches, if the average is 70 and standard deviation is 5, is 0.81859 and so on. So about 81.9% of people are between 65 and 80 inches if that's the data we're using. Now, as another example, we would like to know what's the probability that a male is less than 220 pounds, given that the average weight for adult males in the US is around 200 pounds and the standard deviation is 35 pounds. So we'll go into second vars to get distribution again, go down to normal CDF, and then let's say our mean is 200 and our standard deviation is 35. Now we can have any lower bound we want. We could put 0 because people can't be negative weight, but we could also put a super negative weight just to account for any density that's below 0 somehow. In the normal distribution, it's not limited, remember? It could go from negative infinity to plus infinity. So we'll do minus 1 e to the 99 up until, let's say we wanted to find out if they're less than 220 pounds. We'll go down, paste, enter, enter. And so 71.6% of males who are adults in the US weigh less than 220 pounds, for example. With that same data, let's find out the probability that a male adult in the United States weighs more than 180 pounds. We'll go again to second distribution, go down to normal CDF and hit enter. Then we want to see if they're 180 or more, so the lower is 180. And then upper could be a really high number. You could put 99999 if you want. I like to put 1e to the 99. And then these are the same mean and standard deviation, so we'll just paste and find out that 71.6% of people weigh more than 180 pounds. And note, that's kind of special because of the symmetry. It's the same answer as before because 180 and more should have the same area as 220 and less because they're both 20 away from the mean. Now let's find out the probability that an adult male in the US weighs less than 130 pounds or more than 300 pounds. So we'll have two disjoint regions, so we'll add them together. A person cannot be both less than 130 and more than 300. So what we'll do is we'll go into second vars again, normal CDF. We'll see if we want them to be less than 130, we'll put lower as the super huge negative number, and then up to 130. And then we can add, instead of hitting enter again, we can add another normal CDF function. That will be normal CDF, that they are 300 or larger. So we'll put 1e to the 99, a super huge number. So the probability that a person, an adult male in the US, is less than 130 or larger than 300 is about 2.5% of the adult US male population.